Good day, friends and students and any viewer. We are again going to continue with our presentation on congruency of triangles and their problems related to that. We are going to now start with exercise 7.2. So this would be exercise 7.2. Okay, so this will be, because we have done all examples previously, even up to example 6. That will be in our slides on part 3. You will see a video saying that congruency made easy, and part 3. So this would be our part 4. Okay, this presentation. Okay, so let's start with question number 1, that it says in an isosceles triangle ABC. Once you set it is ABC, you don't have to write anything further. But anyway, it has been said in this particular example with an isosceles triangle as I have drawn, A, B, C. Of course, if it says isosceles triangle, that means we know AB equal to AC and angle B equal to angle C. So this would be definitely given. It says that bisector of B and C intersects at O. Okay, fine. Then it says join A to O. So it's join A to O. Okay, and show that what is the show that is 1 is OB equal to OC, and 2 it is that AO bisects angle A. Okay, so since it says bisects A, and these are said that these are bisectors, that means angle, I can say angle OBC is equal to half of angle B, right? Okay, similarly, angle, I can say angle COB is equal to half of angle C. Since angle B equal to angle C, therefore angle OBC would be equal to angle. Okay, I have started like this, OBC, so I should also change this and write OCB. OCB. Let me maintain this. Okay, angle OCB, would be equal to angle OBC. Okay, so half of that will be equal to. Since these two angles are equal, so therefore BO will be equal to BO, or here it is given as OB. Okay, we will write OB equal to OC. Why? Sides opposite to equal angles are equal. Okay? Sides opposite to equal angles are equal. Okay? So one part is over. So that this is over. Okay, now let's see what is happening. Now in order to prove the other part, the number 2, we have to follow this technique or this procedure. Okay, so we have proven, this is proven, OB equal to OC. So now let us take two triangles. Which are the two triangles we will take? Let us hatch them. I want to take this triangle. We have to take this triangle because the bisector comes here. And we have to take this triangle. We will take these two triangles. Okay? Now let's see what happens. So we start with triangle ABO, ABO, and triangle ACO, ACO. Okay, or ABO and OCO. Let's see what we have got in here. AB equal to AC. AB equal to AC. Okay, AC in this portion. AO is common. AO equal to AO. This is common. Common. There is some friction on the chalk, so you cannot write very fast here. Okay, I'll from next time I'll use this side of it. Okay, and we have just proved OB equal to OC. So OB equal to OC. Okay, we have proven. That means I can easily say that triangle ABO is congruent to triangle ACO by SSS axiom. Okay, it's known now. These are congruent. So what does it mean congruent? That means angle BAO is equal to angle CO. Therefore, AO divides angle A. Is it okay now? You can add another one because again angle BAO plus angle CAO is equal to angle A. This is done. So there is no problem on this. Very easy. First starting point. You don't start on the other side. Starting point. Take this triangle. Okay? And then prove OB equal to OC. OB equal to OC. First. Because once you prove this, then only you can prove this congruency of the triangle. And once you have proven the congruency of the triangle, then only you can prove that AO bisects angle A. You cannot go any other way unless you have done this particular this thing. If you also try, they say that, well, this is equal to this is common, and this angle is equal to this angle. But it doesn't fall, then it will form under what? It will be side, this will be side, okay, it will be also side, angle, side, you can do that also. Side, angle, side, by congruency you can also prove. that this is half, this is half. So these two will, because this is one side and this is one side. No, you cannot prove it, because this angle will not be there, because this is not the included angle here. So this is not included angle here. So this process is also wrong. You cannot use this. So only way you can do it is to prove by the axiom SSS. SSS axiom you have to take. You cannot use this one, because in that way it will be side A. Side and angle. And this is not included angle. This angle is not included between AB and AO. So you would be, and this is not any one of the conditions. So this will not work for this purpose. Okay, then we will again go through, we will erase this part of it and go for question number 2. Okay, let's go to question number 1 will be changed to question number 2. And question number 2 is says, now there is in triangle ABCD, A, B, in triangle it cannot be ABCD, it can be only ABC, because there are 3 vertex only. So AD is perpendicular bisector of BC. AD is the perpendicular, show that okay, let's write here. Show that triangle ABC BC is isosceles triangle. Okay, it sometimes looks L, it should be like C. It should look nice. Okay, so what do I have to do? I have to prove AB equal to AC, right? This is means this. Okay, what is given? It's given this angle is 90 and this angle is 90, because perpendicular bisector of BC. Therefore, BD equal to CD. Okay, this I can say given. Okay, now AD is common. AD is equal to AD. Okay, now these two sides, this side and this side are equal. This is common. Included angle is that 90 degree, so that is also common. So ADB is equal to angle ACD, not ACD, ADC. They are equal to 90 degree. Okay, as AD is perpendicular to BC. Okay, this is C. So therefore, a triangle ABD is congruent to triangle ACD. So what we can say then? AB is equal to AC, that is equal to CPCT. CPCT. Done? Okay, that's what we have been show that. So this is proven. This is shown. Okay, this complete this particular, there is nothing straightforward, a simple. In fact, question number 1 was little bit tougher than question number 2. In fact, they should have given this one a question number 1 and the other one is question number 2. But I don't know the reason for their choice, because they have started with a toughie, but unfortunately the one was a simpler, the following one was a simpler one. So that will sometimes help you a lot. Okay, now let us see question number 3. Question number 3, it says, so let us first change these to 3. It again says ABCD is a triangle, okay, we'll put the numbers later on, in which are drawn on equal sides respectively. So this is, okay, we have to do it. A, B, C. So C to 1, this one has been given as F. This is F and this is given as a 90 degree. This is E. So this is perpendicular. So this one is perpendicular, means this one is perpendicular because they are linear plate. So this one being perpendicular, this one is also perpendicular. Okay, what do we have to do? On equal sides, AB equal to this is. So that these altitudes, so if you if in a triangle, if in a triangle, a perpendicular, I can write perpendicular like this. A perpendicular is drawn from one vertex to the it says opposite side. Let us write opposite side. Opposite side, then it is called an altitude. Okay? So don't get confused. What is this altitude? I don't know. What is this? So this is anyway it's given that these are perpendicular and this is drawn. And it is not necessary that they bisect, so you cannot take that. Okay, what do? We have to take two things we have to take. First of all, we have to select, okay, then what is we have to prove? Okay, so that these altitudes are equal. That means what it is saying? It is saying I have to prove CF is equal to, okay, but why I should start with C? I will start B. BE is equal to CF. Okay, B comes first, so let us maintain that order. This is to be shown. To show. Okay, this is to be shown. Okay, then next should be our choice of triangles. So this one comes in this triangle. Okay, and BE comes within this triangle. Okay, let's see what else we can get out of it. So let us choose those two triangles. So I'll choose those triangles. I'll write triangle. I'll start with AB, ABE, and and on this side I will have triangle ACF. ACF. Okay, let's see what we get out of this. First of all, we know it is given, it is an isosceles triangle is given. It's an isosceles in an isosceles triangle. That means it is also given AB equal to AC given. Okay, so I'll drop it here. AB equal to AC, this is given. Okay, you can also see that angle A is common. So angle A is equal to angle A, which is common. Okay? So this is common. What else I can take? I can definitely take advantage that this angle, this particular angle, that means angle BEA is equal to angle BEA CFA. Okay, this is E. So if they are, it is perpendiculars. That means that's equal to 90 degrees. So this is a side, okay, this is angle, and this is also an angle. Okay, so side, so I can say triangle ABE is congruent with triangle ACF on what axiom? That will be AAS. Okay, AAS or SAA, they are any one of them you can take. This is one of the rules of congruency on this case. Once I have proven congruent, then I can say that BE is equal to CF. Okay, CPCT. Okay, there is nothing. It's a choice of triangles only and taking angles. So you have got two angles and you have got a side. Okay, this side and this side. So this will be angle AAS. It will form under that particular combination of this thing. Okay, now we will go to question number 4. So this is straightforward. This is straightforward. And you don't have any other choice. Okay, and you take the advantage of the angle A is equal. So this second one would be again similar, right, of this thing. Okay, it's the opposite one. Very good, very good. What does it say now? It now is given that this altitude we know, it is again the same one, it is same thing like this. I will not necessarily write it, I can rub this one off and utilize this portion of the board for other activities or for this one, and I can, what I have to now show, it's the opposite way. What it says, that in a triangle ABC in which altitudes BE and CF are drawn, are equal. So it is saying now BE is equal to CF. Is given. This is now given. Okay. I'm not going to change anything. You will be utilized. So these are altitudes. So these are perpendicular. Altitude means they would be perpendicular. This is given. So you have to now prove. This is given, and since this is an isosceles triangle, it says you have to prove that first of all. So if it says this is the one, again, so we try with the triangles. Okay, triangles, same thing, A, B, E, and triangle A. Oh, it's given here. Why I am writing the same thing over and over again? I can use this part itself. So I will not utilize this, but I will come back and utilize this here. So this is not given anyway. In fact, this you have to prove. Then you have to prove this. So this is to be proven. So this is no longer true. So what is true here? This is true is given. Instead of that, it is given BE equal to CF. This is given. This is given. Okay, if this is given, everything goes on. Now this will be this will be now congruent. By this would be this is a side, this is an angle, and this is an angle. Again, this is the same thing, the side and angle and sides. So if that is true, nothing here changes. This is again AAS remains. So now I can say AC, because this is now it is, this will also change. This will, instead of this, you write down only AB equal to AC. AB equal to AC. Okay? So now see the difference. They're the same problem, only it has shown a change. And they have given that these two are equal, these two sides are equal, this angle is common, and these two triangles are equal. Okay, let me go the other way. They have given this and this equal, this is common, and I have to prove AB equal to AC. So these two angles are there, they are 90 degrees, they are given, the same thing has been given here, angle A is common, B is equal to CF, so this is two angles and a side. So AAS. This is done. Okay, since these two are equal, so this is an isosceles triangle. Okay, now let's go to question number 5. Now we will go to question number 5. Question number 5. It says ABCD ABC, the D comes with this thing, and there is a point D here, and you join them together. Okay, so this is given AB equal to AC because they are isosceles triangle. AB equal to AC from this triangle ABC, and angle B equal to angle C. Okay, similarly from triangle BDC, yes, or no, it should be DBC, yes, it should be written like that. It should be DB equal to DC, okay, D equal to DC. Therefore, again, here I cannot write angle B and equal to C in this case. I have to define it much more further. So I need to define it much more further rather than just writing angle BC, because it will then lead to confusion to the next one. Okay, let it get dried up a little bit. So it says that angle here BD equal to DC. BD equal to, if I start with B, then it should be CD. Okay. So there are also, these sides are equal. Okay. Since these sides are equal, then angle DBC should be equal to angle CDA. Okay, here which angle? Angle ABC should be equal to angle C, angle ACB. Okay, these are all given. These are all given. What do we have to prove? Or what do we have to show? To show what? To show angle ABD, that means this whole angle is equal to angle ACB, that is this whole angle. Okay, what do we do? Very easy. Angle ABD, angle ABD is equal to angle ABC plus angle CBD. Okay, right? And angle ABC plus angle CBD, this angle, this is this, and angle ACD would be equal to angle ACB plus angle BCD. Okay, now let us see. It's given angle ABC is equal to angle ACB. So these two triangles are equal, and these two triangles are equal. It's given here. Angle okay, BDC, what side of angle C? I have used CDA. No, this is wrong. This should be DCB, or yes, this should be DCB. DC. So I change that. DCB. And okay, let's write like this, whatever way it has been written here. I have to identify this angle. So I start DBC, and this angle will be again DCB. Okay. So plus ABC plus I have to say DBC. So these nomenclature changes are little bit problematic here. Angle, this should be angle ABC, this should be angle DBC, DBC, and this would be DCB, and this should be angle DCB. Okay, only I change a little bit of nomenclature so that they fit. So these two are equals. Therefore, angle ABD is equal to angle ACD. So that you don't get confused, there is another way of doing the same thing. Mark this 1, 2, 3, 4. Angle ABD is equal to ABD is equal to angle 1 plus angle 2. Angle ACD is equal to angle 4 plus angle 3. Now, angle 1 is equal to angle 4 and angle 1 is equal to angle 4, angle 2 is equal to angle 3. So all these things where you are getting, you can get confused, is eliminated here straightforward. So this angle 1 is equal to angle 2. That means these two are equal, these two are equal. Therefore, you can write angle ABD is equal to angle ACD. I had been advocating this way of nomenclature so that you do not get confused over the whole thing. And I have demonstrated now how much confusion you can get into doing that. And this is writing, timing, all is very, very fast by doing this way. So we'll go to the next one. And now we will be using 1, 2, 3, 4 notations instead of writing this angle like this, once I have demonstrated to you. And this is question number 5 we have done. This is question number 6. It says you have a triangle ABC. Triangle ABC. Okay. And it says... okay, it's an isosceles triangle. This is A, this is B, this is C. This is an isosceles triangle. That means AB equal to AC. And then it says BA is produced to D. Okay, it is produced to D so that AC is equal to produced to D such that AD is equal to AB. So AD is equal to AB. So again, this is also equal. See, if this is AB, then this must be equal to this also. Okay. And join this. So join this. And it says what? Show that angle BCD is a right angle. Angle BCD. So you have to prove this angle. BCD means this angle. You have to prove that one is right angle. So let us write it down. So AB equal to AC, and it is given AD equal to AB. So that is equal to AC. Done. This is given. To show angle DCB is equal to 90 degrees or right angle. Okay, very easy. Let us start doing this. Okay, let us say this is angle 1, this is angle 2, this is angle 3. Oh, let me write. My 3's are getting very. This is angle 1, 2, 3, 4, 5, and let's call this angle 6. First, let us take angle ABC. First angle ABC. In angle ABC, angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Why? The sum of interior angles of a triangle. Okay. Again we take a triangle DEF. AC. Their angle 3 plus angle 5 plus angle 6 is also 180. Same reason. So you can write the same thing here. Sum of interior angles of a triangle. Done? Let us add these two together. That means equation number 1 and equation number 2. Add 1 and 2. What do I get? I get the whole thing. 1, angle 2, angle 3, angle 4, angle 5 plus angle 6. That is equal to 180, 360. Done? Okay, now let us see. These are isosceles triangles. So angle 1 is equal to angle 2. So instead of writing these two, I write it into 2 into angle 2. Right? Then this is also isosceles triangle, 3 and 6. So I will take 3 and 6 and write plus 2 into angle 3. Okay? Now, what is left is 4 and 5. 4 and 5, this angle and this angle would be equal to 180. Why? Why? Linear pair. Why? Linear pair. Okay, done? Okay. Okay, this remains 360. This is equal to 360. ये 360 कहीं नहीं आ रहा. Okay, 360. Okay, then therefore 2 into angle 2 plus 2 into angle 3 will be equal to 180. Okay, let me come up here. So I'll come up here. Okay. So angle, now I'll take 2 common. So take 2 common. So then it becomes angle 2 plus angle 3. That becomes equal to 180. Therefore angle 2 plus angle 3 is equal to 90. Okay? Angle 2 and angle 3 is equal to angle DCB. That is equal to angle DCB is equal to 90 degree. Done? Shown? So shown. So this is simple. If I have to start writing all these angles, it would have taken me a huge amount of time instead of doing like this. This is question number 6. Okay. Right? Okay. Let us finish up another question, which will be question number 7, and you will see that this notation is extremely easy, and this should be done in all questions and answers. The authorities should allow use of these notations, or otherwise you have to define what is angle 1 and write separately and all that kind of thing. You don't need to do those. Okay. Now let us see what does question number, that was question number 6. This is question number 7. 7, it says ABC. ABC is a right angle. ABC is a right angle triangle in which angle A is equal to 90. So let us do it. Okay. So this is right angle at A. Okay. The figure is not given. A, B, and let us call it C. Okay, this is 90. Okay, in which AB equal to AC, in which AB equal to AC. So this and this is equal. If these are equal, these two sides are equal, it makes no difference whether this is a 90 degree. So this and this would be equal. Since AB equal to AC, therefore angle B would be equal to angle C. In this triangle, if we take sum of internal angles of triangle ABC, then you can see angle B plus angle C plus 90 degree is equal to 180. Okay, therefore now B equal to C, therefore twice angle B would be equal to 90 degree. Okay, because minus there, so it will be this 90 will go here, so this will be 90, this is 2B. Therefore angle B is equal to 45 degree, that is equal to angle C. So this is very simple questions. Don't get it complicated. Okay. Now it says another question. That's the last question here. That is question number 8. I thought if we could do this, then our exercise 2.7.2 will be completed. This is number 8, and it says that you have an equilateral triangle, and show that the angles of equilateral triangle. Let's attempt this. It's interesting. Okay. I think it will be very easily done. Let us say, what does it equilateral triangle means? Let us say this is an equilateral triangle. Okay, A, B, C, where all the sides are equal. That means AB equal to AC equal to BC. Okay. Now, since AB equal to AC, therefore angle B would be equal to angle C. Right? AB equal to AC, then this angle and this angle will be same. Okay, now let's use another thing. Let us say this, since this and this angle is same, since AC also is equal to BC, therefore angle B and angle A, angle B would be equal to angle A. Okay, this is done. Again, sum of internal angles, sum of internal angles of a triangle. So that is angle A plus angle B plus angle C is equal to 180. Okay, angle A is equal to angle B equal to angle C, angle B equal to angle C. Since this is also can be written is equal to angle C, because B is equal to angle C. So we can write all these are equal. So I can write angle A plus angle A plus angle A is equal to 180. Therefore 3 angle A is equal to 180. Therefore angle A is equal to 60. Is it okay with you? I think it should be okay with everybody. Done. So this completes our exercise 7.2, and this we have been able to do it in a very nicely in a very small time. And I will again thank you for your patience for listening, and I will request you to like this video as well as subscribe to the channel, because I need a lot of subscription. I have been repeating it in all my videos, but unfortunately the number of subscriptions are not increasing in the way it should increase. Thank you and good day.